Welcome to our physics problem-solving session. Today, we're going to solve a problem about trains and stopping distances. Let's read the problem. On a certain stretch of track, trains run at 60 miles per hour. How far back of a stopped train should a warning torpedo be placed to signal an oncoming train? We're told to assume that the brakes are applied at once to retard the train at a uniform rate of 2 feet per second squared. First, let's understand what's happening in this problem. We have a stopped train and an oncoming train traveling at 60 miles per hour. We need to place a warning torpedo on the track to signal the incoming train to start braking. When the brakes are applied, the train will decelerate at 2 feet per second squared until it comes to a complete stop. Our task is to find out how far back from the stopped train we should place the torpedo so that the incoming train has enough distance to stop safely. To solve this problem, we need to find the distance it takes for the train to stop. We'll use one of the kinematic equations for uniformly accelerated motion. V final squared minus V initial squared equals 2 times acceleration times distance. But before we can use this equation, we need to convert our initial velocity from miles per hour to feet per second to have consistent units with our acceleration. We know that 1 mile equals 5,280 feet, and 1 hour equals 3,600 seconds. Now, let's convert 60 miles per hour to feet per second. We'll multiply 60 miles per hour by 5,280 feet per mile, and then divide by 3,600 seconds per hour. That gives us 60 times 5,280 divided by 3,600, which equals 88 feet per second. So our initial velocity is 88 feet per second. Now that we have our initial velocity in feet per second, let's set up the kinematic equation. We have V final is 0 feet per second. Since the train comes to a stop, V initial is 88 feet per second. Acceleration is negative 2 feet per second squared, since it's decelerating. And we want to find S, the distance. Substituting these values into our equation, 0 squared minus 88 squared equals 2 times negative 2 times S. Let's solve this step by step. On the left side, 0 squared is 0, and 88 squared is 7,744. So we have negative 7,744 equals negative 4s. Dividing both sides by negative 4, S equals 1936 feet. If we want to express this in miles, we divide by 5,280 feet per mile. S equals 0.3667 miles. Now, let's visualize our answer in the context of the original problem. The warning torpedo should be placed 1936 feet back from the stopped train. This gives the incoming train, which is traveling at 60 miles per hour or 88 feet per second, enough distance to decelerate at 2 feet per second squared and come to a complete stop before reaching the stopped train. So our final answer is the warning torpedo should be placed 1936 feet, or approximately 0.3667 miles, back from the stopped train.